Okay. Okay. I assume you guys are sharing my seeing my screen, and you are seeing the first page of the presentation. If not, please let me know. And what I'm gonna do is that I'm gonna go full screen, so I'm not gonna see your messages. So just turn on your mic, say something if you want to ask a question, or if you had any concerns. Okay. So is there any questions before we start the class? No? Okay. So let's go ahead and start the class. We covered all the basics. We covered the syllabus, and today we are going to start talking about the flight controls. Essentially, flight controls are the first step of Lab 1 and Lab 2. Becoming familiar with the flight control, and in the Lab 1 and Lab 2, both of them, you learn how to use a flight simulator, and essentially it is set up in a way that resembles the real flight simulation, real flight essentially. So the goal is for you guys to become familiar with real flight and how to control the different parts of an aircraft, the main parts of an aircraft, if you will. Okay, so we have different types of aircraft control systems. The first one is the flight control systems, which we are going to discuss today. And then the next ones are going to be the cockpit controls, which we will talk a little bit on Wednesday in the next lecture, essentially. And we have the connecting linkages, which we don't talk about that much in this class, just an introduction maybe. And we also have the direction controls, which are essentially a subgroup for the flight control systems. If you want to categorize it differently, or if you want to use different categories, we have three main control groups essentially. Primary flight controls are the first one, which are the most important ones as well. And we also have the secondary flight controls and auxiliary flight controls. So today the discussion is gonna be around the primary flight controls, and we will see a little bit of secondary flight controls, just an introduction. A lot of you are already familiar with these flight controls, but we have to cover them so we make sure everyone is on board with this. And yeah, so the first thing we want to do is to watch a clip that was downloaded from YouTube. It essentially goes over the basics of flight control. It's a 2-minute clip, and you guys have to let me know if you didn't have the sound, if you didn't hear the sound.
An aircraft is an amazing machine, capable of flying in any direction by rotating about in 3 dimensions. These are called axes of movement. The average location of an aircraft's mass is a point that is called the centre of gravity. So if you suspend an aircraft from the centre of gravity by a line like this, the aircraft remains perfectly balanced. Each of the 3 axes moves about the centre of gravity. The aircraft's principal axes are normal axis, drawn from top to bottom, lateral axis, drawn parallel to the wings, and longitudinal axis, drawn from tail to nose. Each axis is perpendicular to the other 2 axes. Let's look at each individually. The rotation about lateral axis is called pitch. This movement changes the vertical direction of the aircraft's nose. rotation about the normal axis is called roll. This is the movement of the nose of the aircraft from side to side. The rotation about the longitudinal axis is called roll. This is the movement of the aircraft's wings. One wing goes up, the opposite wing goes down. So in summary, these are the three principal axes of movement.
Okay, a very short introduction to the uh, axis of control. So to go over them again to make sure that we are all clear, we have three different primary control systems, primary control surfaces. We have ailerons, elevators, and stabilizers, and rudders. Ailerons control the roll, and the roll was essentially the movement in this direction. This movement. No, I'm sorry. This movement is the roll. Yep. And what happened? Yeah. And, um, this movement is the roll of the aircraft, which is controlled by ailerons. We will talk about the mechanisms on how ailerons control the roll in a little bit. And we have the axis of rotation it is rotating around the longitudinal axis, and the stability, which we will discuss more about this different types of stability in flight dynamics and control. You will see that in your flight dynamics and control course, and you will see a little bit in flight and orbital mechanics. The type of stability is called the lateral stability. Okay, so this section it will be discussed in your later courses. And we also have the elevator stabilizer that are usually located at the end of the aircraft. Right? They control pitch and they rotate the aircraft rotation. Pitch rotation is around the lateral axis, and the elevators control the longitudinal stability of the aircraft. We also have rudders that are usually located here. Okay, they control the yaw, which is the movement of aircraft or the rotation of aircraft around the vertical axis. And the stability related to yaw is called the directional stability. Okay, but then the question is, let's start from the elevator. How does elevator control the pitch of the aircraft? Okay, as we mentioned earlier, elevator controls the pitch about the lateral axis. Okay, what happens is when you have the up elevator position, so this is the elevator here, okay, it is in a straight condition. Let's say the elevator starts from here. When you have the up elevator position, something like this, you are decreasing the camber of the elevator, you're decreasing the camber of elevator, right? And this decrease in camber creates a downward aerodynamic force at the end of the aircraft, which means that your nose of the aircraft is gonna go up, and rotation is gonna be around the center of gravity. So your tail is gonna go down, the nose is gonna go up. So you will have a pitch up movement for the nose of the aircraft. Essentially, your aircraft is gonna increase its height, if you will. Okay, and if you do it the other way around, if you move it in this type of position, the down elevator position, you are gonna create a force in this direction, right, the upward direction at the tail, and your nose is gonna pitch down. Okay, this is how your aircraft is gonna decrease the altitude, decrease its uh, altitude essentially. So very simple. Just you play with the aerodynamic forces. You create a force in different directions, and your aircraft is gonna pitch up or pitch down. But there is at the end of the let's just start from here. So your elevator, which is this, is very sensitive to any type of command that comes from the pilot, right? So you control the elevators with moving the stick in these two directions, front and back, right? When you push it front, if you will, when you push it in, if you will, right, the aircraft is gonna go down, it's gonna pitch down. If you pull it toward yourself, the aircraft is gonna go up, and you will see this in the flight simulator lab, hopefully next week, if you decide to come to the lab. And by the way, we are going to upload the labs, a recording of the lab uh, before the next lab, essentially, sometimes next Tuesday in a week. So if you decide not to come to the lab, you can always use that recording. So if you pull it towards yourself, you're gonna have a pitch up movement, and if you pull it away from yourself, if you pull it towards yourself, if you push it away from yourself, you're gonna have a pitch down movement, and this is how the movement is uh, essentially transferred to the elevators. You have a pivot point, and the movement is transformed to an elevator movement using a bell crank. Bell crank is connected to a spring, and this side is connected to the elevator. Okay, so what happens is it is very sensitive to the movement, and we want to reduce its sensitivity. So we introduce an anti-servo tab at the end of the elevator to decrease its sensitivity. The anti-servo labs can also be controlled by the pilot. So sometimes you want to increase the sensitivity, sometimes you want to decrease it. So its movement and how firm it is located in its position is also controlled by the pilot. Okay, is there any questions so far? No? Okay. So let's go to the ailerons. Ailerons are the ones that control the low roll of the aircraft, right? They are attached to the trailing edge of each wing. So if this is your aircraft, very rudimentary drawing of the aircraft, ailerons are essentially located here and here. Ailerons, okay, and they move in the opposite. That the main important part here is that they move in the opposite direction of each other, which was not the case for the different sides of the elevator. Elevator is at the different two sides of the tail, but these two sides essentially serve as one side, and they are connected to each other. So they go up, they go down together. But for the roll and the ailerons, it is not that way. They move in the opposite direction from each other. Okay. Okay. So what happens is when you move the control stick, when you move the stick we saw here, in the to the right, it causes the ailerons on the right wing, essentially. Let me see if I can draw this. Let's say this is your stick. When you move it to the right, what happens on the wing? Let's say this is the wing of the aircraft. What happens on the wing is that this ailerons is gonna deflect upward. Okay, and the left aileron, this is the right aileron, right? And the left aileron is gonna deflect downward. So if there is there anyone who can tell me, and you can just write a comment uh, in the comment area, what's gonna happen? What happens when one of the ailerons move upward and the other one in the opposite direction moves downward? What will happen to the wing? What kind of force analysis we can have, and eventually what's going to happen? Is there anyone who can answer that question? No one? Okay. So we have Josh saying that the lift is gonna decrease on the right wing, and we will have an increased lift on the left wing. Okay. So can you explain to us? You can actually have your mic on if you want to answer this as well. Can you explain to us why that happens? Mm-hmm. That's right. That's right. So essentially, your main control mechanism here is the camber, right? Thank you, Josh. Your main control camber, your main control mechanism here is the camber size. So when you are moving the aileron, when your aileron is deflecting upward, what happens is that you are decreasing the camber of the wing, right? And if you want to take a look at it from side view of the wing, this is going to be your airfoil. And I'm assuming, hopefully, all of you guys have passed aerodynamics. Otherwise, you couldn't have taken this course. So you know what an airfoil is. So this is your airfoil, and you know the camber. It has a very high camber. But in deflect this aileron upwards, we're gonna have something like this. Okay, which means that your camber is gonna be decreased, and with the decreased camber, you're gonna get decreased lift. We will have the opposite mechanism on the other side. Actually, you're going to increase the camber on the left side, and you're going to have higher lift. Okay, this is what we discussed. What's going to happen is that your airplane, because of the force balance, you have higher force on the left wing, which is going to push your uh, aircraft to roll right, essentially. So the force balance is going to be disturbed. Yeah, you can see the stick here. You can see actually a visualization here that we have turned the sticks to the right. You will have an upward deflection of the ailerons here, a downward deflection of the ailerons here. The downward deflection is going to produce more lift, as I mentioned, and also more drag, and we will talk about this. So the added drag, essentially, when you increase the camber or you play with the camber, you are increasing or decreasing the lift and drag together, all of the aerodynamic forces. If you increase the camber, you're going to have higher drag and higher lift. And if you decrease the camber, you're going to have lower drag and lower lift. So let's see this. What's going to happen is that you have let's say you have moved the, so this is actually in the other direction. You have moved the sticks to the left, and your aircraft is gonna roll to the left. Okay, roll in this direction. I cannot draw the roll movement here because it has to be three-dimensional, but hopefully you get the point, right? But you're gonna have a higher drag on this thing as well, right? This drag imbalance is gonna cause what is called an adverse yaw. So this is a yaw you haven't planned for, but it is happening in the adverse of your roll, essentially. It is uh, trying to move the aircraft in the other direction that you don't want to move, right? Because you are trying with, in this picture, essentially, you are trying to roll the aircraft or turn left, right? But it's not going to happen, or it's going to happen with more energy from the pilot because of this adverse yaw, right? And so you have to be mindful of that. And there are a lot of mechanisms that are developed to circumvent this adverse yaw or to reduce the adverse yaw that's going to happen on the ailerons. But yeah, you will have the adverse yaw when you're trying to roll. Okay, but so what is the main mechanism? This should be. What is the main mechanism? And here you see the pictures that shouldn't have been here, but should have been part of the animation. But let's talk about these pictures here. So you have the ailerons deflected up and deflected down. These are called the differential ailerons. You have another type of ailerons called the phrase ailerons, are very popular as well. And that you can see on the right side, essentially, instead of deflecting up and down, they move essentially, and are gonna can control the drag a little bit more compared to the differential ailerons, as you can see here on the race condition. Okay, but the main mechanism we're going to use to control the yaw is rudders, right? Rudders, when you are flying, rudders are there to contract the adverse yaw. But where are rudders located? Rudders are located here at the end of the tail, okay? And the amount of rudder control required is highest at lower airspeeds and high angles of attack, because you're going to have essentially higher drag generation, higher adverse yaws at lower airspeed, higher angle of attack, and obviously at larger aileron deflections. Okay, so let's talk about the rudders a little bit. Essentially, what rudders do is they turn the aircraft. When you are on the ground, you need to turn your aircraft only by using the rudders, because if you do the roll, you're essentially gonna break the wings, right? Because wings are gonna move downwards or upward, and they're gonna collide with the ground essentially. So you're gonna have an accident if you use the uh, ailerons to roll on the ground. So you have to use the yaw. What's gonna happen is that when you move the rudder to the left, you will have, because of that camber increase or decrease again. But if you when you move it to the left, you will have an aerodynamic force created in this direction. So the nose of the aircraft is going to move in the left direction. And the rudder's controls are look like gas pedals, gas and brake pedals on your car. You essentially have to move the left a little bit differently. You will see it in the lab, but you essentially have to move your brake, if you will. If I want to use the car analogy, you have to move it forward to be able to turn left, right? Your rudder is gonna move to the left, and which means that your nose of the aircraft is gonna move to the left. The same is true on the RAF. You have to move the right rudder forward, so your rudder is gonna turn right, and your aircraft nose is gonna turn right as well. So you're gonna turn right. So when you're on the ground, you are gonna use rudder to turn, right, to get to the tarmac and be able to fly. And where you're on the when you're flying, what happens is you essentially use the rudder to control the adverse yaw generated because of the movement of ailerons. Okay, is there any questions so far? No? Okay, so we have the secondary flight control systems. The secondary flight control systems control the indirect movement of aircraft, that essentially indirectly affect the movement of aircraft about these three main axes by increasing your lift or decreasing the drag or the other way around. And a lot of different, they have a lot of different functions actually. We have three main, most of them are installed on wings, the secondary flight control systems. We have three main systems of secondary flight controls that are installed on the wings. You have the leading edge devices or leading edge flaps. You have the trims and you have the flaps or trailing edge flaps. So we can see examples of these devices here. We have the leading edge flap, two types of leading edge flaps that work with increasing or decreasing your camber. Some of them actually are in a fixed slot, some of them are in movable slot. The ones that do the movable slot, these two actually don't control the camber that much, but they do control the flow separation from the wing. So if you remember from your aerodynamics, flow separation is a very important parameter in the stall condition. In when you are flying in a high angle of attack, you want to be able to, or very high speeds, you want to be able to control your flow separation on the wings, right? We also have the trailing edge flap, we have the plane flaps, we have the split flaps that essentially connect stick to the trailing edge when they are closed, but they split from the trailing edge when they are not closed. We have the slotted flaps that move in position. We have the Fowler flap and a combination of the slotted and Fowler flap. So the Fowler flaps, the difference between these two is that the Fowler flaps are essentially move back and forth, but the slotted flaps rotate around this axis. Okay, so you can have a combination of the two as well. The flaps are mostly called the high lift devices. These are called the high lift devices. They are the most common high lift devices, and they are attached to the, as mentioned, they are attached to the trailing edge of the wing. But one of their main functions of these flaps is how they help the pilot control the landing of the aircraft. And landing of the aircraft is the hardest part of the flight. And you will see that in your first lap in the flight simulators. Like flying the plane, especially in the cruise condition, is essentially very simple. Takeoff is the second simplest part of flying, but landing is very hard, is the hardest part of the flying. So essentially what happens is that with the approach to landing, you want to increase the angle of descent without increasing the air speed. Okay, and you use the high lift devices or the flaps for this purpose. As mentioned earlier, we have different types of flaps. We have plain, split, slotted, and Fowler flaps. Let's move on to trims. Trims are designed to essentially help minimize the pilot's workload. These are the systems that are installed that multiply the force that is applied by the pilot to the stick or to the rudder controls or any other controls that you have installed. You have in the cockpit, right? And they aerodynamically assist movement and position of the flight control surfaces to which they're attached. Okay. The most common types of we have seen one specific type of trims before on your elevators. We call them anti-servo, and just like a couple of slides ago. But the other common parts of trims are trim tabs that are adjustable and fixed. We have the anti-servo tabs. We have the balance tabs, and we actually have the adjustable stabilizer on the elevator as well. Okay. And you can see the different aircraft that the anti-servo tabs and the balance tabs are installed on Piper and Cessna. What we are going to use in the lab and what we are going to focus on is going to be the Cessna 172, which is one of the most popular aircrafts. And we have a real flight simulator for that aircraft in McNair Center, in which you can get a pilot license actually using that aircraft if you have a certified trainer sitting beside you. But you'll get to see all of those in the lab. Okay, so different types of trims. You have the elevator, for example. You have the elevator at the end, and you have the trim tab here, which is going to control the sensitivity of the elevator. We also have the anti-servo tabs here. We have the stabilizer as well here. And we also have a trim motor for the elevator. So trims, as I said, are essentially there to help the movement of elevators, ailerons, and rudder, and to increase the pilot's force that's gonna or decrease the pilot force that is being applied on the stick and the rudder control. Okay. So the next part of the discussion is gonna be geared toward landing and takeoff, but we are gonna discuss this part of the lecture in another class, in the next class essentially. So in the next class, we are going to discuss landing and takeoff, a little bit of mathematics. We are going to discuss other types of flight control or aircraft control, which is one of them is the engine control, and we'll get there later. And all of when I'm done with this lecture, I'm going to upload all of this PowerPoint as a PDF file essentially, and you're going to be able to use it for your lab reports and whatever you want to use it for. So do you guys have any questions about anything, about the lecture, about the course in general? Yeah, sure. So I've never met you guys except for Josh, and that's very unfortunate, but hopefully we will meet you next week, next Tuesday. I know some of you have also taken the propulsion course. Who is also in the propulsion course? Except for Josh. Josh. Oh, Nirlep. Am I pronouncing your name correctly? Nirlep? Okay, do you guys hear me now? Okay, that's good. Okay, so we have Trey, Josh, Igor, Nirlep, if I'm pronouncing it correctly, and that's it. We are missing one person. That's all right. You don't need to come to the class. So, do you guys have any questions? Is there a lab this Tuesday? No. If by this Tuesday you mean tomorrow, I think you mean tomorrow. No, there is no lab tomorrow. The lab is gonna be on let me give you a date. It's gonna be on September 1st. Okay, I think which is the a date listed on the syllabus. I think, hopefully. And in that lab, you're gonna learn to fly an airplane and monitor the lift and drag coefficient using a very simple Python program. Sure. Any other questions about the lecture, class, course, whatever, the grading system? Okay, it seems there is no other questions. Let me just uh, finish the class by mentioning this point that as you have seen in the previous lecture, and I'm pretty sure you have checked the syllabus yourself as well, your engagement is very important in this class, and there are a couple of points to your engagement. So your engagement grade is not just something that is there that I'm not gonna give you 20% on your engagement grade. You have to earn the 20%. So you have to be involved in the class. You have to ask questions. You have to do the experiments in the lab. You also have to be uh, answer my questions if I ask any, or your TA's questions. You have to participate in the, like when I ask a question through email or whatever, you have to reply to that email. You have to make sure that you tell me what your opinion is, and these are all parts that go into your engagement grade. So if you don't engage in class, if you don't come to the labs, if you just submit your lab reports, even if you get 100 on everything, on all of your quizzes, your final grade is gonna be 80. You will get a B. Okay. You may ask that you may ask me that you have taken the online part of the class. You don't want to come to the labs, and that's completely acceptable. You have to talk to me through emails. You have to answer my questions. If I ask a question during the recorded lecture, you have to send me an email like answer that question and so far and so forth. Is there any questions about the things I just mentioned? Okay, no. Is there any one of you who doesn't want to come to the lab and wants to watch the recordings on Blackboard? Okay, that's good. So I'm gonna see you guys. We are not gonna have live sessions. I just decided to have this live session so you guys can ask any questions you may have. And the only question was that, is there a lab this Tuesday? So that's good. That means that we are all on the same page. I'm going to do the recording. I'm gonna upload the recording on YouTube and post it on Blackboard. I think it works better for you guys and me, both of us. You of course have the chance to talk to me. You can shoot me an email. We can meet through any medium. It can be Microsoft Teams, it can be Blackboard, or you can come to the lab and ask your questions. I will definitely be there. Your TA will perform the lab, but I will be there. I will sit there and ask any questions you may have. And yeah, stay safe. And I guess that's it for today. Have a good day, guys. This is